Today we're going to build an AI research assistant that can help you with writing papers or a thesis, for example, in Python using LangChain. So the idea is we can provide a topic, we can provide research questions, and maybe even filters like I only am interested in the papers of 2025 and 2026. And then we're going to get interesting papers that are relevant to our subject. We're going to get formulas if applicable, and we're also going to get a simple trend analysis. In the first step, we're going to build the whole thing as a simple CLI application. Then we're going to vibe code a graphical user interface around it to make it look good. And then in the third step, we're going to ground it in actual scientific literature using consensus. This is going to be a very interesting project. So if you like this video, let me know by hitting the like button and subscribing. But now let us get right into it. Alright, so what we're going to do in this video today is we're going to build an AI research assistant in Python. As I mentioned, we're going to do that in LangChain. That is going to be our agentic framework behind the scenes. We're also going to use OpenAI's GPT-5 model as the intelligence for that agent. And in addition to that, we're going to use Pydantic for structured output. Now, why do we need structured output? The reason is because if we want to build a UI around it, we need to be able to expect certain fields, certain information to be present. We cannot just get randomly structured freeform text from the model and then build a UI around it. We need to have certain fields that are always there. And because of this, we're going to define a schema, a model, with a couple of papers, with metadata fields. We're going to have formulas if applicable. We're going to have trend analysis and maybe some part that is free text. But for this, we're going to use Pydantic to allow us to define a structured output model that the agent can then follow. Now we're going to do this in 3 steps. The first step will be a minimal CLI application. So just a proof of concept, just a basic agent. We can provide a topic, research questions, a time frame maybe for the papers, and the model is going to return the structured output, the JSON object then, and that's going to be the first part. The second part is going to be a UI around this model. Now this part is going to be vibe coded. We're not going to write HTML, CSS, and JavaScript ourselves because I don't want to teach that. I don't want to teach you design and animation here. I want to teach you the functional part, the agentic part. So we're going to, of course, do everything that is related to the actual intelligence, to the actual AI part. We're going to do it by hand, but every design aspect of it, we're going to just vibe code. And then in the third step, we're going to see that the results contain a lot of hallucinations or sometimes misinformation or don't find any real papers after a certain knowledge cutoff date. And because of that, we're going to use consensus to actually ground, or to be precise here, consensus MCP, the MCP server, to ground our model in the actual scientific peer-reviewed literature. So the idea is we're going to see what the model gives us without consensus and then also with consensus. Now, for the sake of transparency here, Consensus is sponsoring this video. You will find a link to them in the description down below. All right, so let us get started. I'm going to go into my tutorial directory here in the terminal. Let me go full screen, and I'm going to say UV init to create a new UV project. Now, you don't have to do that. You can also just work with your basic Python installation, and you can install packages using pip install. That's not a problem at all. You can do the exact same thing that I do here without UV. I just prefer to work with UV. So I do UV init, and then to install packages, I do UV add. In your case, you can just go directly and say pip or pip3 install if you have this on your system. And otherwise, you can also create a virtual environment if you know how to do that and if you want to do that. So in my case here, as I said, I'm going to do UV add, and the packages that we're going to need are, on the one hand, LangChain with OpenAI support. So LangChain and then in square brackets, OpenAI. Then, of course, also Pydantic. I'm also going to need a package called python.env to load the OpenAI API key into the environment from a .env file. And I think that's actually it for the packages. So UV add, LangChain, OpenAI, Pydantic, and python.env. Now, in my case here, I already have a .env file. This is what it's called, dot and then env. What is in that file is basically, let me create a second one. Let's call it .env-fake. What I'm going to have here is OpenAI underscore API underscore key written like this, then equals, and then the OpenAI API key that you get from OpenAI. So usually it starts with SK and then whatever. So that is what the file contains. You want to call it .env, and you want to put the OpenAI API key in there. Once you've done that, we can go into the main PY file. I'm going to delete everything here that is created automatically. If you don't have such a file, you just want to create it. And here now I'm going to start with some basic Python imports. I'm going to use JSON. I'm going to also use async IO. Then I'm going to say from .env import load.env. From langchain.agents, I want to use create agent. Or actually, since we're not going to even use any tools here, I'm just going to go with init chat model. So I'm going to say from LangChain chat models, I'm going to say init chat model. And then also from Pydantic import base model. And I'm going to put it here because I like to have the sizes in order. So to explain it briefly, we're going to use async IO, especially because we're going to need it later with the MCP adapters. This is an additional package that we need to add later on for consensus, not for consensus per se, but for using any MCP server. And we're going to use consensus MCP. So we're going to need that. We're going to also load.env here. So the .env file contains the API key. To have it in the environment, we need to actually call load.env. So now this takes the API keys from the .env file and puts them into or pulls them into the application, into the Python script. We're going to use Pydantic, as I said, for the structured output model. This is the next thing that we're going to do here. And then down below, we're going to initialize the chat model, which is going to be GPT-5 with LangChain. So let us get started with the structured output model. For this, I'm going to say class paper. That's going to be the first thing. I want to have in the end a report that contains papers, formulas and everything, but I also need the individual papers. So for the report to contain multiple papers, I need to define what an individual paper looks like. So I'm going to say paper base model. And then I can say title is a string. Then I can say authors is a list of strings. So I can say list and then string. Then I can say year is going to be an integer. And these are required fields. Now, if I want to make a field not required, I can use the pipe symbol here and say or none, which basically means it's an integer or it's not present. So for example, we can say venue is going to be a string or it's going to be none. And I can also set a default, which is none. Now we're going to do the same thing for the URL of this paper. And then we can also add some free-form text like relevance, which is going to be a string. And for this, actually, I need to import also a second class called field. So here we can now add a description to instruct the model what to do with this specific field. So we can say that this is a string and it's a field. And the field has a description, and we can say why this paper is relevant to the topic or research questions. So you get the idea. We can define our structured output like this. Now, for the rest, I'm going to just copy paste it because I don't want to be typing fields here for hours. But basically what we have now here is we have a class formula. Formula, same as paper. We have name is a string. LaTeX is string. This is basically the LaTeX code. So it's basically, if you don't know LaTeX, it's something like if you want to have a fraction, you do \frac and then curly brackets 1, 2. That would be the same as rendering 1/2. And then you can actually render it into an image, which is very useful oftentimes, especially in papers. But here we can get just LaTeX formulas or the LaTeX source for the formula that is provided here. We can get a description and we also get the reference. So actually where this formula comes from. For the trend, we just have title, description, and again, where it comes from. And then we have the report. This one is interesting because here we provide the classes from above as types. So we say that our report has a topic, research questions, time frame, and then we have the papers that we found, the formulas that we found, and the trends that we found. And here you can already see I said 5 to 8. Let's go with 5 to 10. Actually makes more sense. 5 to 10 most relevant papers. So this is now basically our structured output schema or model, whatever you want to call it. And now we're going to define a chat model and we're going to force it to use this model when giving a response. So I'm going to say async def main. Let's maybe say, put this to the top, async def main. And here I want to get the topic. The topic is going to be a user input. I want to ask the user, what is the topic for the paper or thesis? And then we want to strip the input of all spaces and I think new lines as well. I'm not actually entirely sure if this is done by default. But then we're going to do the same thing with the questions. These are going to be the research questions. So we can say, what are the key research questions? Then we can say time frame. It's going to be, what time frame should the papers be from? And all of this is free text, so we don't have to provide a number. We can just provide anything that the model can understand. We're working with language models here, so you can also just provide any instructions you like. Now for the task here, this is basically just a multi-line string. I'm also going to copy paste that because I don't want to type all of this out here. But essentially it's a formatted string. So we have F here, we have topic, research questions, and time frame. So this is what the model will get as input. It will get the task. So it will get a topic, then the questions, and then it knows either no specific focus or what the time frame for the paper should be, and then gather 5 to 10 highly relevant papers, identify the most important mathematical formulas for the subject and recent trends, and then populate the report schema fully. So these are the instructions. Now for the model, we're going to say model is equal to init chat model, and then I'm going to provide here OpenAI/GPT-5, and I'm going to say with underscore structured output. And then I can provide a schema, which is the report schema. Now to actually get a response now from the model, that's the last part actually. We just need to say result is equal to the model, invoke, asynchronous invoke. And then we can just pass a message history. So we have this typical structure of having a list of dictionaries with role and content. So role is going to be system. And then we have the system prompt here. So that's going to say you are a thorough IT research assistant helping write academic papers and theses. And then all we have to do here is we need to copy that. We need to say role user, and the content is going to be the task. So we don't need quotation marks here. We can just say task. And now to actually print the structured output, all we have to do is we need to say print and then json.dump s, dump into string basically. And we're going to take the result.model_dump. And we can say indentation level is going to be 2. That's basically it. The only thing left to do is to say async IO run and then main, like this. That is our proof of concept. So again, what do we do here? We define our schema, our structured output model. This is what our response should look like. We want to have a topic, research question, time frame, and then we want to have a bunch of papers that look like this. We want to have a bunch of formulas that look like this, and we want to have a bunch of trends that look like this. That is what we define. Here we have our prompt. Here we get user input, and our model then just reads the task, extracts information, and fills the structured output model, returns it, and then we print it. That's basically it. Okay, now before we run this, actually, I need to fix 3 mistakes here. One is we need to add a comma here. Also, second one is we cannot just use a slash, we need to use a colon. So OpenAI :GPT-5, not /GPT-5. And then also, very important, we need to, of course, await the asynchronous call. So invoke is asynchronous, so we need to say await that. So I'm gonna save this, and now we can say UV run main py, or if you're not using UV, you can also just say Python or Python 3 main py, in my case UV run main py. Then we can specify the topic and the other stuff. So let's start with recommender systems based exclusively on embedding similarity. That is my research topic. The questions here are: does it outperform, or do they outperform conventional state-of-the-art models? Question mark. And 2 could be, what are useful beyond accuracy metrics? And then I can say only 2026 papers, please. Now this will take a while now, and then we're going to get a big JSON object. So there you go. We have now the JSON object. You can see we have right now here, we are in the formula section. We also have topic here. We have the time frame. We have all the formulas. It didn't find a single paper here for 2026. And also, yeah, we basically have a bunch of trends here, but I'm not sure if all of these papers actually exist. We're going to take a look at all this, but for now, I want to build a UI around it so it's easier to look at. So what I'm going to say now is I'm going to run a Claude code instance here, and I'm going to say, look at main py. This works perfectly fine. Now I need a UI around this that shows the results in a nice way. Use the Pydantic model, or models I should say, as guidance. Build a simple, minimal, but good looking UI and Flask application for this script. So now we're going to vibe code some UI around it. You can do that yourself in a different way if you want to. I just want to show the difference in a nice UI and not in the terminal. All right, so it says it's done. Let's see if it works. It wrote some basic index HTML, result HTML, and an app UI. Of course, we are going to take a look at the code, especially at the backend code. I don't really care about the design too much. But first of all, I want to see if this actually works. So uv run app.py. The reason we're going to take a look at the code is because we need to change something about it to use consensus to ground it in the actual science. So here we have the same functionality, but a different interface. Let's go again, recommender, systems based exclusively on embedding similarity. Research questions are the same as before. And then I can say again, only 2026 papers. Generate report. And there you go. We get the output. We get some papers here, 5 papers, also with links. So we can actually click on this and see if this makes sense. Okay, this one doesn't have a link. This one does have a link. There we have a link. Now this one doesn't exist somehow. I mean, it's not found, not found, not found. And I wouldn't be surprised if this one also doesn't exist. Okay, gets me to some shopping page. So this didn't work out very well. I'm not even sure if these papers exist at all, if they just have a different link. Not really. This exact paper does not exist. Maybe there's a similar one, but you can see the problem here. The tool itself looks nice. We have papers, we have formulas also down here with the LaTeX representation even being rendered here in our Flask application. We also have current trends here. I mean, cosine similarity makes sense, but that's not really an evaluation metric for our model. This is actually not beyond accuracy, so it doesn't really perform very well. But yeah, the concept is useful. Now what we're going to do is we're going to add consensus MCP to actually ground it in the literature. So we're going to force it to use tools provided by the MCP server to find actual papers and useful papers and to give us a reasonable response. But of course, for this, first of all, we need to explore what this is about. And actually, this is not even a prepared part for the video because I don't know what I vibe coded right now. So I have to see what it actually does. So we can explore this together now. And in the app UI is where the magic happens. We still have the same base model. We still have a generate report function, an asynchronous one, same prompt as before, init chat model, structured output, asynchronous invoke, that's basically it. So yeah, actually it's the same code that we had before, nothing new. The question is now, how do we add the MCP server? And there are multiple parts to this because on the one hand, we have to add the MCP server using a package that we don't have installed yet, but also we need to authenticate ourselves with the MCP server, which doesn't work out of the box in LangChain. So we actually need to use an additional tool in order to do that. But let's do one thing after another. So we're going to close this here and I'm going to install the package called langchain-mcp-adapters. And again, you can either say pip install or in my case, uv add. And of course, you should not misspell it, adapters, like this. So then we're going to go into our app UI and we're going to change now how the function here works. So we're still going to get the information here. We're going to define the same system prompt, but then we're going to create an instance here of an MCP client. And for this, of course, we need to first do the import. So we're going to say from LangChain MCP adapters, and then .client import, and then multi-server MCP client, and then also here from this .tools, load MCP tools. So these are the two imports, and then down here we're going to create a client. Client is equal to multi-server MCP client, and that is going to now contain the config for the consensus MCP. So we're going to use a dictionary here with curly brackets, and I'm going to say, first of all, consensus is going to point to another dictionary. So that's going to be the MCP server name here. And in here, we're going to say transport. Now, this is interesting because if you use that with Claude Code, if you use the consensus MCP server with Claude Code, you would use the transport HTTP. But here we're going to use a tool that allows us to work with stdio, with standard input output. And this tool will be called using npx. So actually not npx here, but command is going to be npx. And maybe before we finish writing this, let's take a look at this tool. And this tool is called MCP Remote. I think it's quite well known. Basically, it allows us to use stdio, the stdio transport to communicate with the MCP server. It handles the authentication for us. Of course, for this to work, you need to be logged in to Consensus. So you need to have a Consensus account, you need to be authenticated, then you want to install this tool. So you can just do it in your code the way we're doing it now, or you can also do it in the command line. In this case, what you would do is you would just run the command npx-y mcp remote and then add latest and then the MCP server. So I could just run this and this would run the authentication, discovering OAuth server configuration. It finds that. You can then say control C to exit, and then you're authenticated basically. And you can also do that here in LangChain, and it will do the authentication for you with the npx command. So essentially the same arguments. Down here we can say args is equal to a list, start with -y, and mcp remote at latest, and then https://mcp.consensus.app/mcp. So that is the configuration of this client. Now, what we also want to do is want to create a session, and then in this session, we're going to do everything else. Now, another thing that we need to change is we can no longer just work with a simple chat model. We need to use an agent because now we have tool use, we have MCP. So what I'm going to do is I'm going to replace this here by saying from LangChain agents import create agent. And then from LangChain agents.structured output, we're going to use the tool strategy. So these two imports are what we're going to use now. And we're going to replace our model here by saying agent is equal to create agent. And then I'm going to say model is equal to OpenAI GPT, actually not 4.0, but 5. I'm not sure why I changed the model. Did I use 4.0 before? I think I used 5. But yeah, we can do it like this, or actually even better, sorry for improvising now, but we can keep the model. We can remove the structured output. I'm still going to use 5, not 4.0. And we can just use this model now in an agent. Now for this, of course, I need to make sure that I still import the previous things. So LangChain chat models and the init chat model will still be imported. I can go back down and I can say agent is equal to create agent. And then I can say model is equal to model. This is possible. Also, I want to say parallel tool calls is equal to false, just because I had some issues with that. But what I actually want to do now is I want to create a session. So with this client now here, I want to create a new session that uses the MCP tools. So async with client.session. Let's call this one consensus, and as session. We're going to do all of this within this context. And what I want to do is I want to load the tools that are available. So tools is going to be equal to, and now I want to load the consensus tools from the MCP server. So await, and then load MCP tools for this session. The session is related to the client. The client knows the MCP server. So the last thing that we need to do is we need to change how we do the asynchronous invoke. We need to change where the system prompt is. So I'm going to actually take this text here. I'm going to copy it. I'm going to say that that is the system prompt. So system prompt is going to be equal to what I just copied. Then also I want to say tools is equal to tools. I know usually you don't leave spaces around the equal sign, but now I want to just do it. And then for the response format, since we don't have this with structured output anymore, for the response format, we're going to say tool strategy of report. And of course, don't forget all the commas. Then last but not least, we're going to get rid of this. I'm going to say result is equal to await agent asynchronous invoke. I'm going to pass here a dictionary containing messages. Messages is going to point to a list of dictionaries. We're only going to have one entry here. The role is going to be the user role, and the content is going to be the task. And now we need to just return the structured output field of the result. So result and then structured output. I hope I didn't make mistakes, but let's see. It's going to tell us if I did. Let's go and do uv run app py. Now we have the same thing as before. I can just use the same stuff that I had before. So we have here again, recommended systems based exclusively on embedding similarity. Do they outperform conventional state-of-the-art models? Useful, what are useful metrics? And then 2026 papers only. Now you can already see that the MCP remote here uses the MCP server, so we can see the authentication here in the logs. And of course I did a mistake because I set structured output even though the field is called structured response. You need to be accurate with stuff like this. So structured response is the field we're looking for. Let's try again. So same input, generate report. And there you go, we get some results. And here we have 10 papers, 11 formulas, 7 trends. This looks much more professional. We have a bunch of papers, all of them from 2026. All of them seem to have a link leading to consensus. So I can click on this here, rethinking ANN-based retrieval. And it takes me to a consensus page. We can see here also the abstract. We can see the year, the actual publication date, the people that are involved here. So this is not hallucination. This is an actual research paper. Now, this is not a well-known one. It has 0 citations, but we can look at the references of this paper and all that. But yeah, obviously, if it's such a niche topic and it's 2026 only, we're not going to get the state-of-the-art best papers published in all the greatest journals. We see here unknown journal for most of them. I mean, here we have computers in education. Let's click on this one. But it also doesn't have really any citations. But these are real papers, and if I don't limit it to 2026, I'm also going to get more interesting ones. When we go to the formulas, you can see that we actually have more reasonable metrics here. Yeah, this is exactly what I was expecting. Now, this one I would still consider like accuracy, but intralist diversity, novelty via self-information, catalog coverage, these are exactly the things that I'm looking for here. So I'm not looking for precision and recall. I'm definitely not looking for cosine similarity, even though this one was also listed here. But you can see that these here, I can also see where they come from. So I can copy this maybe and Google it. Okay, so maybe that's the paper that this is referring to, but I didn't require an actual URL to the paper, so that's fine. And then we have also current trends. Embedding first retrieval is increasingly state of practice, often matching or exceeding prior state of the art in retrieval candidate generation. And we have here the 2 papers that seem to indicate that. So I can also type them into Google and we can see that there is an actual archive paper actually published in 2026. And this is like day and night difference in the quality of the results that we get here. Now, to be fair, this is a very simplistic tool. I only get some papers, formulas, and trends. You can make this much more complicated. You can save the stuff. You can then maybe ask the AI to rewrite something or to write part of your thesis. But it's very important that when you do scientific work, you don't get hallucinations, you don't get papers that don't exist, and this is what allows you basically to build reliable research technology or research agents. So yeah, this is what consensus does here. To recap, what did we do? We had a LangChain agent. LangChain is the agentic framework that just coordinates everything. We have a pydantic structured output model that defines what we're expecting from the model. We use GPT-5 for the actual generation. And we added the consensus MCP server so that we can actually access real papers, real research, and not just hallucinations. Or I think I remember a paper from 2004, even though I asked for 2026. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Also, as I mentioned, check out Consensus, the sponsor of this video today. You will find a link to them in the description down below. And besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.